Okay, so this is part 2 of our B part on the quadratic functions and graphing quadratic functions. So the last part that you did last day was on how to draw a graph from an equation, and now what we're going to do is we're going to look at how can we get an equation, either from looking at a graph or from given points. So we'll come back to the your turn after we're going to start here on the example. So it says a parabola with a vertex 1, negative 2 passes through the point 4, 1. Write an equation for the parabola in the form y is equal to a times x plus or minus p squared plus or minus q. So looking at this, it's given us our vertex. So our vertex is at PQ, so that means we know that our P is equal to 1 and our Q is equal to negative 2. They've given us the point that it goes through, so that means they've given us an X value of 4 and a Y value of 1. So what we have here is things we can substitute into our vertex graphing form equation that we can then use to find the value of A. So by substituting into the equation, we have the general form of it, and I'm just going to go with, instead of writing the plus or minus for the P's and Q's, I'm just going to write it in this way, which is what you'll usually see in your textbook. So from here we know that our Y value was a 1. We don't have an A. They told us that X was 4. Now our P is a 1, so to go back into the equation it has to be the opposite sign, so negative. And we square that, and our Q was a negative 2. So just use order of operations to solve for this. So if I have a minus 2, I'm going to add 2 to both sides. So I have 3 is equal to A times 4 minus 1 is 3. 3 all squared is 9. So that means I'm left with A times 9 on this side, so I divide by 9, so 1/3 is equal to A. So that means from my equation here, I could figure out now that my equation for this parabola would be at y is equal to 1/3 x minus 1 all squared minus 2. So your equation would be finished from there. With graphing, so this is how you would do it algebraically. To do this with graphing, you would plot your points. Okay, so I plot my points. My vertex was at 1 and negative 2, so it was here. And the point that they gave me was at 4 and 1. So 1, 2, 3, 4, 1. So that means I would do my count. So for this one, my count is 1, 2, 3 up. And 1, 2, 3 over. It's supposed to be, if you remember, if it's 3 up. Sorry, I wrote that as 3. It should be 3 over 3 up. Wrong spot here. So it should have gone 3 over 3 up. And what we should be going is, if we go 3 over, we should be going 9 up. So that means we did 3 over 9. So it means our A is 1/3. So really for this one, instead of going in the direction I did here, I should have done my overs first, and that's just to keep it a little less confusing. So it should have been 1, 2, 3 over, and 1, 2, 3 up. Okay, so you can do it just by graphing it, but sometimes if you forget to do what I just did there and did the 3 over 3 or 3 up 3 over, then you mix those 2 points up and then you can end up having an a value of a 3 instead of an a value of a 1/3. So the graphing one is good to do as a check, but the algebraic one will get to the right answer. So x-intercept. So we know that an x-intercept is when a graph crosses the x-axis. You can find this by looking at the graph, which they just call inspection. Or the other way is algebraically, by setting y is equal to 0 and then solve for x. So that's what you would have done for linear equations. When you had y is equal to mx plus b to find the x-intercept, you let y equal 0 and then solve for x. So a parabola then can have 0, 1, or 2 x-intercepts. Oops. So to have 0, that would mean that your parabola would be going like this, or it could also be going down, and it could be in any of the quadrants. I'm just giving you 2 examples, but it won't be going anywhere near that x-intercept. It'll always be, or the x-axis, it'll always be going away from the x-axis. So to have one x-intercept, that means that your parabola will be touching that x-intercept. Whoops, trying to make my, so it'll come down, it'll go right to that, and it'll have that one little spot where it touches. And again, it could go up, or it could go down. And then to have 2 x-intercepts means that your graph has to cut that x-axis. So it could be going up in that direction or down in that direction. So it says determine the number of x-intercepts for each quadratic function without graphing. So what you do is when it tells you to do it without actually drawing the whole parabola for this, is you take a look at your vertex. So my vertex for this one, vertex, remember, is at PQ, so I take the opposite sign, so it's at 7, -1. My A value is negative. So I know my parabola is going to be going in that direction. If I think where a vertex is 7 and -1 is going to be, if you think of where your quadrants are, I've got a positive 7 and a -1, so it's going to be down in here. 7, -1 will put me here in quadrant 4. So if it's going down in quadrant 4, the graph won't touch the x-axis. So therefore there are no x-intercepts. So if I think about just sketching this, 7, -1 was somewhere about here. My graph, because of that A being negative, is going down this way. So it doesn't actually, whoops, doesn't actually touch that x-intercept. It's right below it. So in the B one, my vertex for this one There's nothing being added on to that squared value, so I know that my p is a 0 and my q is a negative 6. My a is positive, so my parabola will be going up. So if I think about where 0 and negative 6 is, that's going to put me right on the y-axis. So that means that my parabola is going to be just, or my vertex is going to be just below the x-axis. So it cuts the x-axis in two places because it's going up. So therefore there would be two x-intercepts. So this one on a sketch would look something like that. So I've got an x-intercept here and an x-intercept there. Third example, if I look at my vertex, my p is it's 1 inside the bracket, so it's going to be at negative 1. There's nothing being added or subtracted, so I know my q is a 0, which means if it's negative 1, 0, it's going to be right on the x-axis. A is negative, so my parabola is going down. So that means if it's right on, if the vertex is right on the x-axis, then it's going to be touching it at that one exact spot. So that means there is one x-intercept. So graph is touching x-axis at vertex. So this one would look, what was it? Let's say this is negative 1, 0 right here, so it would be going, whoop, my alignment's a little bit off, but it would be going down just like that. Okay, now I'm just going to scoot up to the top of the page here in your textbook to that your turn on page 153. What it's asking you to do is take a look at the information they've given you. There's two graphs there, and they want you to find the equation for each graph. Just have to pause here for 1 minute. Okay, you should have had a chance just to look at the question. So if we look at that graph, we know that the x-intercept from looking at the graph is at negative 3, 0. Or not the x, well, I guess it is the x-intercept too, but in this case I was talking vertex. So our vertex is at negative 3, 0. Then if you do the count from here, it's going over 1 and down half. So if we go over 1, down half, and then the other, if you look at from the next point, you'd be going, if you tried to go over 2, you would go down, down 2. Normally we'd be going over 1, down 1, over 2, down 4, so that means that my A is half of what it normally is. So from there I can write my equation. This graph is going down, so I know A is negative. So my equation would be negative 1/2 x plus 3, because I switched the sign of the p, all squared. You could put plus 0, but you don't need to include that 0 for the p. So you do the same thing again for B. You take a look at the vertex. The vertex is at 2, 1. If you do your count from the vertex, you're going over 1, up 1, 2, 3, 4. Now normal is over 1, up 1, so that means that my A is equal to 4. And it's going to be a positive 4 because my graph is going up. So that means my equation, if I substitute in, will be 4 times x opposite sign of the p, so minus 2 squared plus 1. And then you are finished. So this was a fairly short little lesson to do the last parts of those questions. So on your assignment, those would be the questions that you didn't do last time, which I believe are 8 BCD, 9 CD, 12, and 14. So it would be a good idea to work on those questions now and then bring to class whatever you couldn't do, and then we'll be working on some other questions in the room together.